Hello, everyone. My name is Edward. So I work at ConfidentialMind. At ConfidentialMind, we are building a Kubernetes-based stack, infra stack for generative AI applications. So, for example, if you are an enterprise company and you don't want to put your data in the cloud and you want to keep your data in-house, you would use our stack to deploy your Gen AI products. Add time over. So a bit about myself. So I actually come from a background of biochemistry. I'm pretty self-taught when it comes to machine learning. I worked 4 years at a computer vision startup, Sharper Shape, before ConfidentialMind, and in November last year, I joined ConfidentialMind to transition to NLP and building RAG. So the reason we're building RAG is we want to offer a layer of AI IP for our clients so they could quickly deploy and get value immediately. So yeah, the content of my talk. First, we're going to go over vanilla RAG and some of its limitations. And I think for many of you, this will be a pretty familiar topic. And then we're going to talk about techniques to address the failure modes, some of the advanced techniques, so that we can look into advanced modular RAG. And then if time permits, maybe a brief introduction to agentic RAG. However, I guess the next talk will be more about this, my suspicion is. So don't want to steal their thunder. But let's see how we do on time. So yeah, retrieval-augmented generation. So standalone large language models. If you ask it a question that it might not know, that's not inside their internal knowledge, then you essentially have a non-parametric query that it might hallucinate with trying to respond to. So RAG kind of combines or gives the large language model external knowledge so it can generate more grounded responses and increase accuracy and answer quality. So of course, there's a lot of application space from chatbots, QA systems, coding, co-pilots, etc. And generally, it's cheaper than fine-tuning in that if you are, say, a startup, you would have to support a lot of MLOps infrastructure to support the training and experimentation and so on. And also in cases like, say, you have a knowledge base that might change very often, like code documentation. Once you fine-tune, you've kind of locked the knowledge into that language model. So RAG is sort of a more cost-efficient solution there. So yeah, brief overview with vanilla RAG. You have the, I'll just go and, yeah. So over here, you have the user interface where the user can ask a question. And over here, let's say the user connects the RAG with internal knowledge. So for example, you can upload documents. Documents get chunked, and the document chunks gets embedded by a bioencoder model. And you store these vector embeddings into a vector store. And then the query over here, the query gets encoded by the same bioencoder usually. So you want to keep the vector distribution. And then what you can do is you can perform semantic search using dot product to get the most semantically similar retrieval items from your vector store. And then from there, you augment your prompt to generate a response. So there's various failure modes, and this is not an exhaustive list, but just to name a few. So for example, queries can be vague, especially if you think about how humans, how we communicate with each other in messaging apps, or how we might use AI. We can insert some very vague queries that might confuse the AI in trying to understand our intent. Retrieval items can be mismatched with what we really want, what might be more relevant to our intent as well. Context window limits are an obvious one. Incomplete knowledge base. So if you don't have the right information in your knowledge base, the language model, the retrieval process might not actually find the relevant information because it's not in your database. And then also the LLM might misinterpret the retrieved context, especially in complex scenarios. And complex queries may be inefficiently answered. So to address that, there's a lot of techniques out there. I probably don't know them all, and we definitely can't cover them all. So I'm going to present a few techniques that we found. So when I joined in November at ConfidentialMind, these are some techniques that I've implemented really quickly to find some very nice performance gains, and I thought I would just share them with you today. And also, I want to point out that I think it's a great idea to, if you are working on RAG systems, to make it modular. So you would have composable pipelines that introduce flexibility. So say you have a configuration where you can define what retrieval pattern to utilize, or what sort of generation, what type of chunking, etc. So if you make it composable and flexible like this, it will become a lot easier to tune, and I'll get into that a bit later. So yeah, first idea, query modification. So how can we improve the query that the user input to get more meaningful retrieval? So this is not an exhaustive list again, but two methods that I want to point out. One is query expansion. So you can add terms that are similar to the original query. So an example here is if the original query was autonomous driving ethics, you can use an LLM, for example, to generate something like autonomous driving ethics, moral dilemmas, trolley problems, self-driving cars, liability, et cetera, et cetera. And this will help in the process of retrieving items that might be more explicitly stating these terms. So that can help a lot. Hypothetical document embedding is quite an elegant idea. The idea is, if you think about how cosine retrieval works, right? Dense retrieval, what you're doing is you're trying to capture the semantic meaning from the query to the documents. But if you were to have the language model try to hypothesize the answer to the query, then you might start with, when you're performing the cosine similarity, you might find that the answer hypothesis is more semantically similar to the document you're trying to retrieve, or at least it can, at a higher level, kind of capture that semantic space. So that really can help with your retrieval. So all of these are ways to improve the recall of your retrieval. Some more ways to improve recall is to use sparse retrievers in a hybrid way with your dense retrieval. So by dense, I mean like vector embeddings, and by sparse, I mean something like keyword matching with TF-IDF term frequency inverse document frequency with a saturation function, or BM25. So for example, up here I have the example of treatment options for type 2 diabetes, where BM25 will look for exact terms like treatment or diabetes in the document. Splayed, on the other hand, expands the terminology with learned weights. So this sort of helps guide the process in a more fine-tuned way than BM25. So an obvious idea there is that you can fine-tune splayed as well on a given domain if you are interested in that. And dense retriever, of course, is the standard way. And here you would get something semantically discussing the medication for glucose management. So another example I like to give is, say, you have a bug while you're coding and you're trying to look up this specific error code. Now, if you were to use a dense retriever, you might get some results that are about something related to what the error is about, but not exactly this error code you want to read. So BM25 in some ways will help address that. So what you want to do is you want to retrieve, say, for example, with BM25 and with the dense retriever, combine the results with reciprocal rank fusion, and then, and then you would have more results. So now we've improved the recall quite a lot of our retrieval. So how do we improve the precision? So one idea here is to use a cross encoder. So cross encoders are typically fine-tuned BERT variants or derivatives. What they do is you're passing the query and document through the transformer, and it can give you a relevant score with much more closer attention to the passage. And one kind of limitation here is that rerankers are quite slow. So you wouldn't use rerankers on your entire knowledge store. Instead, a good idea is to get a lot of items from sparse retrieval and dense retrieval, combine them, deduplicate the results, take the candidate items, and then run these, like say, the top 200 returns, and then run them through the re-ranking. And we found that this is actually quite fast if you do it this way, and it dramatically improves your precision. So we've introduced a lot of new hyperparameters into our RAG system. So to list a few, we have temperature of the query expansion, the chunk size, the max chunks, the top K inputs to the re-ranker, BM25 parameters like K1 and B, and so on, right? So how do we tune our RAG system? Do we do it manually? That would be a little inefficient. So what might work also for one client or use case might also not work very well for another. So if you spend, many days trying to optimize your RAG system for say one client, and it works quite well for them now, and then your other client, you use the same configuration, and you find that it doesn't really work well for them. So what is a better way to do this? The idea that came to my head when I was tackling this problem was to use Bayesian optimization. So you can use tree-based Parson estimation. So build a distribution around the threshold to see which one would be, which parameter space would be above the threshold and which would be below. And you can kind of guide the evaluator to find the right parameters and hone in instead of doing like a full grid search over all the parameter space. And by doing this, it can kind of zero in on the configuration that really works well for a given test set that you have. And it's actually quite easy to build if you use open source tools like Optuna. I actually vibe coded this in like 2 days, and it works really well. So yeah, this is just some like example test that I ran real quick. So using the hotpot QA, and by no means is this like an exhaustive or definitive result or anything, but it really kind of highlights, I think, the improvements you can find. So hotpot QA is a pretty difficult data set. It's a multi-hop question answering data set. And so on the top row, the dense, that's basically your vanilla RAG, and you see that the scores are pretty low. And when we add the hybrid retrieval, it goes up. We add the re-ranker, it goes up even more. Ignore contextual embeddings. But contextual embeddings, I won't cover today, but this is basically the method that Anthropic kind of presents in one of their blogs. It's actually quite good. Query expansion, performs even better. One kind of caveat we found is query expansion doesn't seem to play well with hybrid VM25 and reranker. So interesting finding, but that might just be specific to Hotbot QA. ASG reasoning is an internal experiment that my colleague's working on. It's a reasoning module to add to the generator part of the RAG system. So we can ignore that from now. But if you're interested in graph RAG, I would go to his talk. And on the bottom here, we see a huge jump yet once more. And that's just with like a few hours of Bayesian optimization. It just found the right configuration that found some really good performance. So yeah. Some quick mentions. Colbert, late interaction models are really strong. So when you're choosing embedding models, I think one kind of easy decision or choice one might make is to look at the top embedding model in Hugging Face leaderboard. But what you might find is that Colbert can outperform a lot of those models in the top part of the leaderboard. So what Colbert does is it encodes both the query and document, but at the token level instead of at the size of the chunk. And from there, it takes each. So you have here the query broken down into token embeddings, and you have the passage broken down into token embeddings. And then you perform a maxim operation for each and every query against each other. And then you take the sum of this, and that's your relevance score. And so essentially what you're doing here is you're having a much more granular comparison between the query and the document. So for example, one way I like to explain this is if you think about, say, you have a document or a document chunk that's 512 tokens long. If you were to encode that into one vector, you've kind of diluted a lot of semantic meaning into that one vector, right? So Colbert kind of addresses this problem by breaking it down into semantic level vectors. So one challenge and limitation here, especially if you are the data engineers that might be in this room, is the offline indexing. It can be quite challenging to tackle, but I believe there's a lot of adaptations and improvements to Colbert these days that support indexing for approximate nearest neighbor search and so on. So definitely check out Colbert. And also another aside comment, if you're working with multimodality, there is also a Colbert-like late interaction method for images as well. So it separates out or you take an image and divide it into patches, and then you can also do maxim operations like this. And I believe that's called colpoly and colquen. So definitely check those out. I will have a lot of like the links and stuff to my presentation notes. So if you're on the Discord channel or if you see the my talk presentation slides and you want to find some of these stuff, the links are in the slides. So yeah, some limitations of advanced RAG. So complex multi-hop queries are still very challenging. So for example, an easy version of this would be like, what is the main product of the employer of the person who is giving the first talk at Supercell on March 12? So hop 1 here would be events at Supercell on March 12, and then hop 2, and then from there going on to find the list of presenters. Hop 2 would be finding, going from the first presenter and then finding where I work. And then hop 3 would be going from where I work to finding the product, right? So that's quite difficult, especially if you're doing a single hop RAG. So there are strategies to try and tackle this. Also, a very hard problem would be something like what's on the bottom here. What lessons from renewable energy policies in Europe can be applied to developing nations, and what are the potential economic impacts? There you would have to get the policy data, synthesize the information, contextualize for developing regions, do some analysis, etc. And you have to somehow keep everything coherent as you do your RAG. So I believe, and I think this is my interpretation of RAG lore, if you will. I could be wrong. And if you're like a professor or something, please let me know. But I believe the precursor to agentic RAG is IRCOT. And IRCOT has many of the components that agentic RAG has. It has reasoning, and it tries to find information until it feels that it has sufficient information to answer. It identifies knowledge gaps by applying self-critique, and it formulates retrieval queries, and it integrates the retrieved information. So in a lot of ways, if you think about agentic RAG, this kind of sounds like it, right? But it has a fixed workflow pattern, so it can basically only do one pipeline over and over and over again. So that's where agentic RAG comes in, and I think this is like the paradigm shift that's happening right now. And I think maybe the next presentation might touch on this, or at least my theory is that agentic code tools would use RAG, but let's see. But yeah, what if RAG can be made sentient and can decide how to answer and autonomously solve the goal or reach the goal that it has, which is answering your query. Here I'm, of course, using the word sentient as a joke. So examples of this do exist in the wild, like Anthropic Claude Code. Has anyone tried Claude Code? It's pretty amazing. I think a similar tool to that is Aider Chat. Also OpenAI Deep Research, Grok Deep Search, Manus, which turned out to be Claude backend with like 20 plus tools. Zilla's Deep Searcher is like an open source copy of, I believe, Deep Research. It's not very performant, but it's more educational from my understanding. And then there's also Hugging Face Open Deep Research. So we know that it works and there is a way to do this correctly. But my kind of understanding is that there's no dominant system architecture for agentic RAG. There's many ways to do this, but there are themes. And typically what you will find is that they have these core components. You typically have a reasoning module. They interpret the query, they generate the response, they keep the whole process coherent. You have a memory management. So maybe some of you would have seen, I believe it was Sonnet playing Pokemon. Once in a while, you'll see that like the screen changes and there's like a notepad or something and it fills with information. So that's like an example of long-term memory management. So it's keeping track of the information and compiling that as it goes. You have planning, reflection, and self-critique. So self-critique we kind of touched upon, but so it decomposes the task, tries to understand the user intent. It tries to formulate subqueries and tries to understand if it needs more information, and it will try to perform retrieval using that subqueries. So it also, another hallmark is that it has access to tools like vector search, web search, APIs, sandboxes for coding, etc. So yeah, I think, yeah. So yeah. I think I'll probably end my talk there. But yeah, any questions?
Does these things work? Does this work? Yeah. Any questions?
Yeah.
Hello. Okay. Yeah. If you go to slide 7, if I remember correctly, you were calling it query augmentation or query expansion. Yeah. Isn't it like you are increasing the probability of hallucination over there because your LLM is expanding your original query, which you are using for the cosine similarity? So the query itself is coming from the non-parametric. So the knowledge is not in the parametric, but you're using it to expand. So it's increasing the hallucination probability, right?
So that's a very astute observation. I believe that there are ways to mitigate this in that. So the way I kind of tried to frame it is you're increasing the recall of the retrieval, and some of them are going to be unrelated or bad and lead to hallucinations. But the idea is if you pair this method with other strategies, you might find that like, for example, if you were to use a re-ranker, maybe it would kind of lower the rank, if you will, of the wrong context, so it would reduce the hallucination. So there are ways to kind of mitigate this. And of course, like all the strategies here, they're not perfect. Like, and they all introduce their own problems in some ways. So yeah, but excellent question.
Like a question on the model. So like when you see an increase in kind of the capability of the model, does that always transform to better performing sort of RAG pipelines?
That's a good question as well. So I think there is some like trade-off decision that you would have to make in like how small of a model that you want versus how large. And also if your RAG design requires reasoning because you're using something like IRCOT or agentic RAG, you probably do want a larger model that has reasoning. If I remember correctly, one thing that OpenAI had to do to get deep research working was they had to do a lot of reinforcement learning, like with the reasoning module, to sort of like allow it to understand the processes and steps that it would have to make to generate those plans and so on. So I think it kind of depends. On a more simple RAG system, I think you can do a lot more trading off, but yeah.
Just a general question. What sort of models are you typically using in your research? Because I'm very interested in models and I have been playing with them today as well. So,
yeah, great question. So if you were to ask me, or if you were to ask my colleague, the other member of our AI team, you would have two completely different answers. For me, I just kind of want to build the system correctly and make sure it works. So right now I'm just using Llama 3, 70 billion for most of my tests, just to like ensure things are working end to end. My colleague, on the other hand, he's like trying everything that comes out. So I'm more of a let's make this system work first, and yeah. But yeah, there's a lot of cool models out there for sure, and yeah. But mostly we use open source models as we want to try to replicate what our clients would kind of experience when they deploy on premise.
Thank you.
First here.
Thank you. I have a question about if you tried fine-tuning the model for your RAG pipeline or not.
Which model?
I mean, Llama 3 or any model, or you just use the out-of-the-box model, just put it in your RAG and see if it works.
Yeah. So no, we don't. We haven't done any fine-tuning with our generator model, for example. So kind of like the premise that I wanted to start with was perhaps like here, right? Like at the bottom. So one kind of reason or decision point that some companies might have is instead of fine-tuning models, they would want to build a RAG system instead to kind of handle the external knowledge. In our case, we are thinking about fine-tuning, for example, Splade, which is the sparse retriever, which can help with like vocabulary expansion and so on. So, but yeah, and also maybe like an adjacent point to that is that we are also thinking about figuring out a way to collect synthetic data as well. Had a wonderful discussion with Flow AI team last week about this, and it seems very hard. But yeah, that would technically feed back into a way so you can collect the data to do the fine tuning. But yeah, it's a challenging problem in and of itself, but we haven't touched that.
But like based on my own experience, I mean, fine tuning is not actually more expensive. I mean, it depends how, like if you consider the time, then sometimes with fine tuning, you get the problem solved in faster, basically.
The training process itself might be cheaper, but the infrastructure side and collecting the data could be really expensive.
If you collect high quality data, even if it helps a lot. And you can use LoRa for just fine tuning. I mean, you don't have to go for full fine tuning. Yeah, of course, that would be really expensive. But I have some kind of experience in that, and fine tuning usually works better than trying to put a lot of stuff, tools and stuff, to make the RAG works.
Yeah, no, absolutely. And especially if there's like data sets out there on Hugging Face or somewhere, and the data set's very relevant to like the domain of how you're using RAG, then absolutely, like that is a wonderful way to go about it. But in a lot of cases, like in enterprise scenarios, like this is impossible. So, yeah.
Hey, maybe I can formulate my question. It's about hypothetical document embedding. That you were saying originally one of the reasons to use RAG is because like the original model you're using might have no knowledge at all of like your specific domain, and yet here you're asking it to generate something here. So doesn't this, like, I know it does work, but doesn't this seem like intuitively it would not work?
Yeah, actually, you raise another really great point. So hypothetically, this could be, you could backfire a lot here, right? Like, what if it hallucinates and then you're like retrieving some hallucination? Absolutely, like that could be a problem. But I think there are ways to maybe mitigate that as well. Like if you prompt it in a way to sort of try to reformulate the answer in concepts rather than like direct answers, then maybe you can capture the semantic space around. So like here, right, the example is what causes a car battery to drain overnight. So maybe dense retrieval might not really look at parasitic drains from electrical components or something like this. But then by hypothesizing this, you might have more deeper retrieval in that specific domain, if that makes sense.
Yeah.
But yeah, no, you're absolutely right. There are limitations to all the techniques presented here.
Thanks.
So you had the Bayesian optimization thing, and I was curious if you're planning to do something like this in your product, because are you kind of worried that it's overfitting towards your benchmark there with the hyperparameters?
Yeah, great point. So the Bayesian optimizer, I think there are, how would I say this? So there is no training involved per se, but yeah, no, there is a chance of overfitting to exactly what you said. So one thing I would say to maybe kind of answer that is you don't want to optimize it on a benchmark that, that's not related to your client use case, right?
Yeah.
You want to collect the client data and then somehow generate a labeled data set from there and then try to fit to that.
Yeah.
Yeah.
Which might be a little bit tricky in our product.
Yep.
Yeah.
Data is always the problem.
So I was just going to comment about that it was a really cool experiment with the hotbot QA, but eventually like you need to be able to optimize your system like with your own data and system.
Exactly.
And we have had talks with Ed about this beforehand, and what he just answered to you, basically, you need to be able to create these test sets, and it can be a very challenging task. But if anyone is interested in talking about, you can come talk to me. It might help with the networking as well. So thanks.
Wow, this is brilliant stuff. Sorry, one more comment. So have you actually, because fine-tuning and RAG are not sort of mutually exclusive, and in our experience, actually the combination is the best. Fine-tuning with small amount of data and then doing RAG on top of that is way better than doing actually just one or the other. So have you done experiments with sort of low amounts of that? Because especially with smaller models, it becomes more and more important, because without fine-tuning, small models usually behave really, really badly for some specific cases. But the bigger model you pick, and for example, if you use GPT-4o, you can do most things with the base model, but it's more expensive than some other options. But have you experimented at all with the combination?
So yeah, the Bayesian optimizer was, at least like personally speaking from my work with ConfidentialMind, it's just kind of been a quick experiment so far, like more of a POC that it would work, the concept. But one other problem is that we could try it with some benchmarks, but it kind of runs into the same problem because we don't collect client data. Yeah, so that is a big problem we have to kind of solve. But
yeah, I guess you can. If you are just doing it with the training specific benchmark set, then it doesn't make sense to use any fine tuning because you are sort of poisoning the pool at that point. So.
Yeah, it's definitely a decision point. Like like do we pivot into becoming like a RAG company and go in that vertical, or do we stay more on the infra side and just not collect any data and try to make something very generic that would work for most use cases? It's something we're trying to figure out ourselves.
All right, I think we need to move on to the next presentation.